look at this very quickly. We look at the geometric series and we want to look at the proof of it. We want to contemplate the following sequence. Okay, and I will give you I'll give you AR, I'll give you AR squared, and we will then have ARN minus, let's say minus 2, ARN minus 1, and leave it there. Of course, you know that this is the first term, this is the second term, this is the third term, this is the term before the last term, and this is the last term, which would be Tn. Okay, so Sn can be written as in this format: A plus AR plus AR squared plus ARN minus 2 plus AR plus ARN minus 1. Okay, now the thing that we are going to do to this is that we are going to multiply Sn with R. We're going to multiply Sn with R. Guys, notice what happens. If I multiply A by R, I will have AR. So I multiply this by R, and therefore I got AR. If I multiply AR by, If I multiply AR by R, I will get AR squared. I think you agree with me. If I multiply AR squared by R, I will get AR cubed. Okay, so this will be AR cubed. If I multiply ARN minus 2, this one, if I multiply it by R, remember when the bases are the same, you add the exponents. So this is the same as over 1. So this is ARN minus 2 plus 1, which is ARN minus 1. So that is ARN minus 1. And if I multiply ARN minus 1 by R, I will have again ARN minus 1 plus 1. So this is ARN. Okay, that is ARN. That is what you will have there. Alright, so that is the result that we get there. And here we then want to say, we want to call this equation 1, we want to call this equation 2. And we will then say equation 2 minus equation 1. Okay, so let us write down what is our equation 2. Our equation 2 is positive, so that is RSN AR. And we have to be careful here. AR plus, I forgot A, so, yeah, no, I'm right. AR plus AR squared plus AR cubed, dot, plus ARN minus 1 plus ARN. The negative here says multiply me by negative. So this is negative Sn equals 2. This goes alone, so I put it here. It will be negative A, okay, because it's being multiplied by negative. This will be, check this out, this will be negative AR. This will be negative AR squared. In the dot, there is negative AR cubed in the dot, okay, and then this is plus. Then this is ARN minus 1. Sorry about that. Then we have this here, because this one is also accommodated in the dot. And then we take this. This is negative ARN minus 1. Okay. And of course, there's nothing here. There's nothing in equation 1 that accommodates ARN. All right. There's nothing in equation 1 that accommodates ARN. I think I made some mistakes, but I hope you were able to see them. All right. Then add this and this. You're having RSN minus SN. This and this just gives us negative A. Notice what happens this here and here we just get 0. Here and here we just get 0. Here and here we just get 0. And so this will continue until we get here. It will continue. This and this we get 0, and this is ARN. Okay, I hope you will look at the video, and if I made mistakes with my words, hopefully my writing makes up for that. So this is RSN minus SN equals to minus A plus ARN. Okay, we can choose to write it this way as RSN minus SN, ARN minus A. Okay, here we can take out a common difference of SN, and therefore we'll be left with 1 minus, we'll be left with R minus 1. And here we can take out a common difference of A. We will be left with Rn minus 1. We can solve for Sn by dividing both sides by 2, by R minus 1, divide by R minus 1, so that this and this cancels out. Sn equals to Arn minus 1 divided by R minus 1. All right. This formula, guys, works if you are having R being greater than 1. All right, we will now consider the case where you're having R when R is less than 1, and I will just erase everything here because really it is still the same format, just slightly different. Really the same format, just slightly different. Instead of saying subtract equation 2 by 1, we will say subtract equation 1 by 2. Okay, so we are just changing the order in which we did this. Okay, so now Sn this time becomes what, guys? It becomes positive. All right, so Sn, now we are having Sn equals to A plus AR squared dot plus AR minus 2 plus ARN minus 1. Okay, now this becomes negative now. Very important. This now becomes negative so that we have RSN. All right, now this is negative AR, this is negative AR squared, and AR minus 2, guys, really is accommodated in the dot. But let me just write it. It's accommodated in the dot. Okay, the dot is all the numbers that that are infinite that you can see, minus AR minus 2, and then here is this part. Here is this part minus ARN minus 1, and then that is plus ARN. Okay. All right. Now this and this is Sn minus R. This is Sn minus RSN. This and this gives us A. Notice this and this will give us 0. This and this will give us 0. This and this will give us 0, dot, 0. This and this will give us 0. And then, of course, this is ARN. Okay, so this is Sn equals to R, Sn equals to A plus ARN. Now, what we can do from here is that we can decide to take out the common difference. All right, so here this is minus. We can say our common difference is Sn 1 minus R, and then our common difference here is A. Okay, this is minus. Yeah, this is minus. That's a mistake. This is minus. Okay, minus. This is 1 minus Rn. Divide both sides by 1 minus Rn. 1 minus R. Therefore, Sn equals to cancel A 1 minus Rn, and that is 1 minus R. All right. So that is the proofs. Please go through them. The formulas are this. If you're having r greater than 1, Sn equals to a Rn minus 1 r minus 1. If you're having r less than 1, that is a constant ratio less than 1, Sn equals to a 1 minus Rn divided by 1 minus r. Alright, so that is the main formulas that we will be using. Let's get to the examples. I will give you the first example. Example 1. We will say evaluate, and I'll give you 25 plus 50 plus 100, and we will say plus dot 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 to 6 terms. First question is, what type of sequence is this? Well, 50 divided by 25 is 2, 100 divided by 50 is 2, so this is a geometric sequence. Okay, so you must first establish what type of sequence are you dealing with. So r equals to T2 divided by T1, so that is 50 divided by 25, which is 2, and r equals to T3 divided by T2, that is 100 divided by 50, which is 2. Therefore, this is a geometric series. I will furthermore say, since r is greater than 1, then we must apply the following formula. Sn equals to a Rn minus 1 r minus 1. Okay, let us state what are we given. We are given that a is 25. A is 25. We are given that r is 2. And the number of terms, they said to 6 terms. The number of terms is 6. The number of terms is 6. So we then apply all of that into our formula. Sn equals to a. Okay, Sn equals to a Rn minus 1 r minus 1. Therefore, this is 25, and then this is 2 to the exponent 6 minus 1, and of course that is 2 minus 1. All right, that is important. So that is 25. Then 2 to the exponent 6 minus 1 is 63. Okay, divided by 1. And of course, the answer there is 1,575. All right. So that is the first example. All right. Then let's look at example 2. And I will say to you, evaluate. And I'll give you 32. 16 and 8, and I will say to 6 terms. And of course, here we can see that this is a geometric sequence. Divide this. Okay, so that is 16 over 32, that is 1 over 2, and that is 8 divided by 16, that is 1 over 2. Therefore, this is a geometric series. Okay, then let us state what are we given. And before we are stating what are we given, let us look at r. We notice that r is less than 1, therefore the applicable formula is a 1 minus Rn, and that is 1 minus r. So let us state what are we given. Well, we are given that the value of a is 32. Value of a is 32. We are given that the value of r is 1 over 2. And we are told that the number of terms, I believe it's 6 terms. We are given 6 terms. So we can then apply the formula a 1 minus Rn, 1 minus r, Sn equals to, the value of a here is 32. That is 1 minus 1 over 2 to the exponent 6, 1 minus 1 over 2. Okay, simplification, and this is 6. Okay, I hope I remember to write that. In the previous examples, yes, this is S6. Good. This is S6 equals to 63. Okay, simplify that, please. All right, let's look at example 3. We'll say if let's say if 2 plus 6 plus 18 plus dot 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 is equals to 728. We want to determine the value of n. All right, first let us state that we're given A is 2, and of course you can say that this is T2 divided by T1, and then this is 6 divided by 2, which is 3, and this is T3 divided by T2, that is 18 divided by 6, which is 3. Therefore this is a geometric series. Okay, so therefore we will use the formula Sn equals to A Rn minus 1 R minus 1. All right, we don't know what is the value of n. We are trying to look for that, but we know that the sum must add up to 728. We know that the first term is 2. We know that the common difference is 3. Okay, we are looking for n. This is n minus 1, and this is 3 minus 1. All right, I hope you are following what I'm doing. So then this is 728 to 3n minus 1 divided by 2, cancel. This is 728 equals to 3n minus 1. Okay, this is 729 equals to 3n. Then this can be written as 3 to the exponent 6, and this is that. And therefore, when the bases are the same, we equate the exponents. Therefore, there are 6 terms that add up to, what was the value that they gave us? 728 to 728. All right, guys, that is all the examples that you need to know.